So in 13.1, we're going to be looking at just kind of an overview of parent graphs. We've done parent graphs before, so we're just going to go over just a couple graphs you should be familiar with and how we shift them. So start with the absolute value of x. We've plugged in numbers in here before, but the absolute value of a negative makes it positive. So the absolute value of negative 2 makes it positive. The absolute value of negative 1. Absolute value of 0 is 0. Absolute value of 1 is 1. 2 is 2. 3 is 3. So you kind of fill in the points. We've done this before. You have the parent graph. 0, 0, 1, 1, 2, 2, negative 1. So this would be one that you should know. But if you're not sure, you can always plot some points and remember what this looks like. I do want to review the domain. Since the graph goes left forever and right forever, our domain here is going to be all real numbers, or from negative infinity to infinity. Our range, it does not go up and down forever. It goes up forever, but it has a lowest point. On the y value, the lowest point is 0. So we would say that y is greater than or equal to 0, or we could put it as 0 to infinity. Either one I'm fine with. Well, what happens when we shift it? Well, we ignore it and we graph the parent graph, and then we shift. And we're going to practice some of that. But basically, the A is what it's done before, is going to stretch and shrink the graph. The H is going to be a horizontal shift. The K is going to be our vertical shift. Our domain is still going to be left forever and right forever, so it will stay the same. Because it goes left and right forever, whether I shift it left or right. But the range will change. Because if the graph shifts up or down, that changes our lowest point. So basically it will be y is greater than or equal to whatever k is, whatever that vertical shift is, or from k to infinity. So if I asked you to graph the absolute value of x minus 1 plus 2, we could ignore the shifting and plot the points we know. Zero, 0, 1, 1, 2, 2, negative 1, 1, negative 2, 2. Ignore the shifting, just graph the parent graph. Graph, this is basically y is equal to absolute value of x. Step 2, we're going to shift it. H, or horizontal shift, is opposite. Meaning, here it's a 1, so this will shift 1 to the right. K is our vertical shift. This one's not opposite. So 2 means it will shift it 2 up. So basically each of these points gets shifted 1 to the right and up 2. So I take this point, go right 1, up 2, plot a new point. Right 1, up 2, plot a point. Right 1, up 2, plot a point. And this is what our final graph looks like. The same as the parent graph, just shifted 1 to the right and up 2. Ignore the shifting, graph the parent graph points, and then shift those points, and you have your final graph. But what's our domain? What do we say? Left forever, right forever. Doesn't change. What is the range? Well, it doesn't go down forever. This time it stops at 2. That's our k. So basically, y is greater than or equal to 2, or we could put from 2 to infinity. You should know how to graph square root of x. We've done this before. Square root of 0 is 0, square root of 1 is 1, square root of 2 is messy. It's 1 point something, right? But we could pick another point that we know is nice. Like, for instance, we could do the square root of 4. Well, square root of 4 is 2. So there's some nice clean points. What about negative 1? Well, the square root of negative 1 is not real. So we're not going to graph that. So we just are going to have a point starting at 0, 1, 1, 2, complicated, 3, 4, till it gets up to 2. This is the parent graph. You should be able to graph the square root of x. And if you don't remember what that graph looks like, you should be able to plot some points and get a quick sketch. What is the domain? Left, not forever. This time it starts at 0. X greater than or equal to 0, or you could say from 0 to infinity. The y does not go down forever. It starts at 0, so y greater than or equal to 0, or 0 to infinity. What if it's a cube root? Well, how's it different? Well, the cube root of 0 is 0, cube root of 1 is 1, cube root of 2 is complicated, so I'm not going to graph that point. I want a nice cube root. How about the cube root of 8? That would be 2, 0, 0, 1, 1, 2, 3, 4, 5, 6, 7, 8 before it gets to 2. How is this one different than the last one? Well, the third root of negative 1 is negative 1. It actually has a solution this time. The third root of negative 8 is negative 2. 2, 3, 4, 5, 6, 7, 8. So the idea is what? You end up with a domain going left and right forever. So our domain here is all real numbers. Our range, now it goes up and down forever, is also all real numbers. Or negative infinity to infinity. But this is nothing new. We've seen this before. You should be able to graph a square root of x. You should be able to graph a cube root of x. And if you're not sure, you should be able to plot enough points until you can see it. What if we shift it? Well, we've done h and k before, so that's nothing new. Our domain will shift. Our domain was x is greater than or equal to, so this will be x is greater than or equal to h, or h to infinity. Our range, y was greater than or equal to k, or k to infinity. On this one, the domain and range both still stay all real numbers. So how do I graph the square root of x minus 2? I take the parent graph, and I shift it. Negative 2 is an h, so that will shift it 2 to the right. So all I do is take these points and move them 2 to the right. Take this point and move it 2 to the right. Take this point and move it 2 to the right. What does it look like? Just like the parent, only shifted 2 to the right. I messed up on that though, sorry. For the square root, we would not have this negative part, so I hope you were catching that. The square root was just this top part. Now, that only gets shifted 2 to the right. There is no negative on that. Sorry about that. What's our domain? Well, it got shifted. So, x is greater than or equal to, now 2, that's h. The range didn't get shifted up or down, so it would be y still greater than or equal to 0. This one, I'm going to take now the 3 points. This is the parent graph for a cubic, and I'm going to move them what? 2 to the right and 1 up. So each of these points gets shifted 2 to the right and up 1, 2 to the right and up 1. This one also, 2 to the right and up 1. What does this graph look like? Just like its parent, just shifted 2 to the right and up 1. Domain, all real numbers. Range, all real numbers. Cubic doesn't have any restrictions like the square roots do. Last but not least, this one's probably a little more complicated. I don't think we spent a lot of time playing with this, but you should be able to graph some points here. Okay? Rational equations. We start off with 1 divided by 0. That is not defined. We don't define dividing by 0. So this graph actually has an asymptote there. X cannot equal 0. You can't divide by 0. We could do 1. 1 divided by 1 is 1. 1 divided by 2 is 1/2. That gives me a couple points. 1, 1. 2 gives me 1/2. 3 would give me 1/3, then 1/4, then 1. What does this graph look like? Well, this side is getting closer and closer to 0. What happens right here between these two numbers? If you're not sure, check a number. Check a number between 0 and 1, like 0.5. What is 1 divided by 0.5? That should give us 2. So this graph basically, when I divide by small numbers, gets really big. What happens with the negatives? Can we divide by negatives? Sure we can. 1 divided by negative 1 is negative 1. 1 divided by negative 2 is negative 1/2. This looks very similar to the other side. It's just occurring on the negatives. So it's also getting closer and closer to 0. And here, what happens if I divide by really small negative numbers, like negative 0.5? 1 divided by negative 0.5 would be negative 2. So it does the same thing as the other graph, basically gets closer and closer to 0. Okay? What is the domain? Well, the graph goes right forever, it goes left forever. But there's a big old hole in the middle, right? Basically, x cannot equal 0. Or you could say it goes from negative infinity to 0, or 0 to infinity. What is the range? Well, it goes up forever, it goes down forever, but there's a hole. It never reaches that 0. So actually, y will never also equal 0. Or negative infinity to 0, 0 to infinity. I expect this one to be a little more complicated. I'm not making this an A-basket issue, but they might pop up in the homework. This would be the parent graph. How would we shift it? Well, the domain would shift. So x cannot equal h. The range would shift so that y will not equal k. What does that do with this graph? Well, I can take the parent graph that we had and I can shift it. Shift it how? Well, 4 to the left and down 1. That shifts the asymptote on x cannot equal 4. Negative 4, sorry. 1, 2, 3, 4. This vertical asymptote here got shifted to the left 4. The horizontal asymptote, y couldn't equal 0. Now y couldn't equal negative 1. So this one, x cannot equal, what do we say, negative 4, and y will not equal negative 1. So negative 1, it creates this other horizontal asymptote. What does the final graph look like? Just like the parent. It's identical. So all you would do is sketch a graph that looks just like the parent graph. It has just been shifted 4 to the left and down 1. I know this looks complicated to you, but in all honesty, I can read this no problem. I can tell the first one is the parent graph, kind of get those dotted points on there, and then shift it all 4 to the left and down 1.